Now, dear student of class 12, today I'll continue with the derivative. Now, today's topic is the differentiation of implicit function. Implicit function means now in one equations if there are more than one variable. In one equation there are more than one variable. Now say x square plus example x square plus 2xy minus y square equals to 0. Over in this equation x is the variable, y is also variable. So there are two different functions are over here. One is x, another is y. Variables, actually not the functions, these are the variables. Now there are two different variables. So in the first equation and second equation also you'll get x cube plus y cube minus 3axy equals to 0. This 3 is constant. Now over here in this equation also x is a variable, y is also variable, and x is independent, y is dependent variable in case of implicit function. If x is independent and y is dependent, then you have to differentiate this equation with respect to x, then you have to find dy by dx. Now to solve these equations you will get new concept of derivative. Now say you know about these things, dy dx of x square, we did these things. Derivative of x square is directly we can write 2x and the derivative of x is 1. But in the same case, if you ask to differentiate y square with respect to x, first you have to differentiate the power function. Same way, x square is 2x, y square will be 2y. But y you have to differentiate with x, then you have to add dy upon dx. Similarly, dy dx of, let us suppose, if it is y to the power 5, what you will do? First power function, 5y to the power 5 minus 1 n x to the power n minus 1 formula into y with respect to x is dy over dx. You may get this kind of concept also in case of implicit. Let us suppose if it is log y, the derivative of log y. Derivative of log x is 1 by x. But in case of log y, what you have to do next? First you have to differentiate log. Derivative log x is 1 by x. Similarly, derivative log y will be 1 upon y. Into you have to differentiate y. Then we'll write dy upon dx. The derivative of implicit functions, that you have to remember this concept. Now suppose if you get this kind of functions, x into y, then you have to use u into v formula. U dy dx of y plus y dy dx of x. Now then x, derivative y is dy upon dx plus y, derivative of x is 1. Now if you learn this concept of implicit function, differentiation of the implicit y with respect to x, it will be easy for you to understand the implicit for derivative of implicit functions. Now next I'll apply the same thing in numericals. Now the question, if x square plus y square is equals to a square, find dy by dx. Actually this one is the equation of circle. Now we'll just try to calculate the slope of the circle. Actually dy by dx means the slope. Now so this one is implicit, since x square plus y square is equals to a square. Now differentiate this function. Differentiating with respect to x, it will be 2x, derivative x square is 2x, plus in case of derivative y square with respect to x, then first derivative y square is 2y, then y with respect to x is dy by dx. Then a square is constant and the derivative of any constant is 0. Now then I'll write 2y dy by dx is equals to minus 2x. These two quantities get cancelled, therefore dy by dx is equals to minus x upon y. So is the required answer. Now this is another question, same implicit function. And now the question is, since x square minus 2xy plus y square minus 2x equals to 0. Now then derivative, differentiating with respect to x, derivative of x square 2x minus 2 Now it is x into y, so that you have to use u into v formula. The u into v formula is u dy dx of v plus v dy dx of u. Clear? U into v plus derivative y square is 2y, then dy upon dx minus 2 derivative x is 1 equals to 0. 2x minus 2x, this is dy upon dx plus y, derivative x is 1, 2y dy by dx minus 2 is equals to 0. Now then I'll open this bracket, it is 2x dy upon dx minus 2y plus 2y dy upon dx minus 2 equals to 0. Now in this equation we have two different quantities, two derivatives of it, dy by dx. So I'll take common. From these two expressions, this and this, I'll take 2 and dy by dx common. From these two expressions, if I take 2 and dy by dx common, what remain over here? First I'll write positive. 2 is common, dy by dx is common, then y will remain over here. Over here 2 is common, dy by dx common, it will be minus x equals to. Now these two quantities, these three quantities, I'll bring from left hand side to the right hand side. So I'll bring these quantities. First I'll bring this one. This is 2 plus 2y minus 2x. Again from this also, the common is 2. Y minus x dy by dx. Take 2 common, it will be 1 plus y minus x. This 2 get cancelled. Therefore, dy by dx will be dx is equals to, it will be 1 plus y minus x over y minus x. This one is the derivative of this equation. Now this question is a little different. This is y and x variable. So in the previous video I did this kind of questions. Now, so in previous video I did variable to the power variable. Now this is dy by dx. Now how to differentiate x to the power y? Variable to the power variable means this is in terms of dy by dx of u to the power v form. If the question is u to the power v form, how to differentiate? U to the power v dy by dx of v into log u. This is a formula. After that you have to use u into v formula. Now say the same formula I'll apply over here. This is also implicit. This kind of questions are important for the boards. Differentiating with respect to x. Then directly you can write dy by dx equals to. Now say then I'll write dy dx of x to the power y. Now dy dx of x to the power y means it is in terms of u to the power v form. Now apply that formula. U to the power v, then dy dx of v into log u. U means x. Now then x to the power y, I'll apply u into v formula. U dy dx of v plus v dy dx of u. X to the power y, then y, derivative log x is 1 upon x plus log x into dy dx of y is dy upon dx. Now then I'll solve over here. Now it was dy by dx equals to, now then just open this bracket, it will be y over x into x to the power y plus x to the power y log x into dy by dx. Now then I'll write the like terms on one side. That means like term means dy by dx containing terms. Dx minus, I'll bring this quantity only, x to the power y log x dy upon dx equals to y into x to the power y over x. Now then just take dy by dx common. If you take common, it will be 1 minus x to the power y log x equals to, therefore dy by dx equals to y into x to the power y over x into 1 minus x to the power y log x. Derivative of this kind of functions. This is very, very important. Now another question. Now the question is, since y to the power y is equals to e to the power x plus y. Now say this question, first function, y to the power y means it is in terms of u to the power v form. We'll apply this formula. Second one is direct derivatives. Now differentiating with respect to x, dy dx of y to the power y is equals to, now the derivative of e to the power x plus y, first you have to differentiate the exponential. Derivative to the power x is e to the power x plus y into, now the four functions. Now I'll differentiate this one, this quantity. Derivative x is 1 plus derivative y is dy by dx. Now then y to the power y means how to differentiate? Y to the power y dy by dx of y into log y equals to, now say in place of this e to the power x plus y, now say over here e to the power x plus y is there. Now in place of e to the power x plus y, from the question we can write e to the power x plus y means in place of this we can replace this by y to the power y. Now then y to the power y use u into v, u dy by dx of v log y plus log y into dy by dx of y to the power y 1 plus dy upon dx, so that we can cancel this two. It is y. Now over here we will get the derivative of log y. First you have to differentiate log, that is 1 by y, and derivative y is dy over dx plus log y into dy by dx of y is dy upon dx equals to 1 plus dy over dx. These two quantities get cancelled. Now after simplification, now we have over here dy over dx plus log y dy upon dx equals to 1 plus dy over dx. These two quantities also get cancelled. Now it is log y dy upon dx equals to 1. Therefore dy by dx is equals to 1 over log y. That's the required answer. Now this much we'll do from the implicit function. Our next video will be of the derivative of parametric functions. Thank you.